A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hi. Since childhood, many people have been entertained by connecting a bulb and a battery to illuminate it. We have already understood that from where the power required to light the bulb is obtained. The current from the battery is called direct current. Is the battery the only source of DC? We will see. This is a DC generator. Let's see its part and how it works. In the previous case, we have seen that both the LEDs are glowing alternatively. The current which was generated there is AC. But when you look at here, you can see that while rotating the armature in one direction, blue LED is glowing. While rotating in the opposite direction, the red LED is glowing. Why is it happening so? Let's take a look at this. This is the working model of a DC generator. Let's see what are the different parts of a DC generator. Armature is one of the most important parts of a generator. It is an arrangement where insulated copper wire is wounded over a soft iron core. This armature sits in between two powerful magnets and it can rotate freely about an axis. This is the north pole and this is the south pole. We know that the electric field lines are always from north pole to south pole. These magnets create a strong magnetic flux inside the generator. Another important part is shown here. These are split rings. In the previous case, we have discussed about slip rings, but now we are not considering them. Let's take split rings into consideration. Two semicircular split rings R1 and R2 can be seen here. Here, the split ring R1 is touching the graphite brush B1 and the split ring R2 is touching the brush B2. That is, the generator is designed in such a way that both the split rings are always in constant contact with any of the brushes, but they are not connected together. Now, let's see what is happening inside the generator. This is the 0-degree position of the armature coil. We know that the magnetic field lines are from north pole to south pole. In this position, the magnetic field lines are parallel to the armature coil and hence field lines are passing through the armature without getting interrupted. So, there is no change in flux and hence the induced EMF and current is 0. After a 90-degree rotation, the armature coil aligns at this position. Here, the magnetic field lines and the armature coil align in a perpendicular direction. That is, armature is cutting maximum field lines. So, the change in magnetic flux will be maximum and hence the induced EMF and the current will also be maximum. CD is now facing the north pole and it is rotating downwards. So, a current is induced in the respective direction and the direction is said to be positive. After rotating further 90 degrees, the armature aligns at an angle of 180 degrees. The position is similar to the 0-degree position. That is, armature coil is parallel to the magnetic field lines. So, there is no change in flux and hence no induced EMF and current. Armature rotates through another 90 degrees and aligns at 270-degree position. This portion which was facing the north pole before is now facing the south pole. Here, the magnetic field lines and the armature coil aligns in a perpendicular direction. That is, the armature coil is cutting maximum magnetic field lines. So, the change in flux is maximum and hence the induced EMF and current are also maximum. When you observe, we can see that at a 90-degree position, the CD was moving downwards and hence the direction of induced current was considered as positive. But when it comes to 270-degree position, CD is moving upwards, that is, the direction of motion is reversed and hence the direction of reduced current is also reversed. This is considered as a negative direction. The armature again rotates another 90 degree and aligns at 360-degree position. This is similar to the initial condition and 180-degree condition. Armature and the magnetic field lines are parallel and hence there is no change in flux, no induced EMF and no induced current. Here we can say that the armature has completed a full rotation. The current induced here is flowing through the external circuits through rings and brushes. When the armature rotates, split rings interchanges its position. As we have said earlier, at 90 degrees, the direction of induced current was taken as positive and at 270 degrees, it was taken as negative. So, it is clear that the current is changing directions. That is, AC is forming in the armature. So, let us consider the position of split rings here. Now, let us examine the direction of induced current in each cases using Fleming's right hand rule. This is the 90-degree position of the armature. A, B, C, D points are shown here. At this position, the motion of CD is downwards. Let us apply Fleming's right hand rule here. Magnetic field lines are from north to south. So, if we stretch the forefinger in this direction and the thumb in the downward direction, the middle finger, which is perpendicular to both the fingers, will give the direction of induced current. So, here we can see that the current is flowing in this direction. That is, from DC to R1 to B1 to the external circuit to B2 to R2 and then goes back to the armature. Armature rotates from 90 degree to 270 degrees. This is the 270 degree position of the armature. Let us apply Fleming's right hand rule here. CD is now facing the south pole and the rotation of CD is now upwards. So, stretch the thumb in the direction of CD. Direction of magnetic field lines are from north pole to south pole. So, stretch the forefinger towards the direction of the magnetic field. Then, the middle finger, which is perpendicular to both the fingers, will give the direction of induced current. Induced current is flowing from CD to R2 to B1 to the external circuit to B2 to R1, then goes back to the armature. Now, let us discuss an important concept here. The position of split rings interchanges with the rotation of the armature. At 90 degrees, the ring R1 touches the brush B1 and the ring R2 touches the brush B2. Here, the current flows from B1 to B2. As the armature rotates, split rings interchanges its position. When the armature rotates from 90 degree to 270 degree, the position of the split rings get interchanged. So, at 270 degrees, the split ring R2 touches the brush B1 instead of B2 and the split ring R1 touches the brush B2, not B1. Here also, the current flows from B1 to B2. That's why the AC in the armature coil is converted to a unidirectional current due to the interchange of split rings. That is, whichever may be the ring through which the current is flowing, it is always in contact with the brush B1. So, the direction of current is always from B1 to the external circuit to B2. In the 90 degree position and in the 270 degree position, the current is flowing from B1 to B2. So, from this, it is clear that although the armature rotates continuously, the induced current is always flowing from B1 to B2. That is, the direction of current never changes. To be more precise, the current which generated in the armature was AC. But since we use split rings instead of slip rings, and since the split rings are commutating, we are getting DC as the output. That's why we can say that the current we got here is a direct current or DC. Now we can explain why only one LED glows when the armature is rotated in one direction. Because DC is unidirectional. If we rotate the armature in one direction, we get a DC of that direction. So, the blue LED glows. If we rotate the armature in the opposite direction, the direction of DC also get reversed and hence the red LED glow. If the information is represented as a graph, we will get a graph of DC current as seen here. The mechanical energy we supply in a DC generator is converted into electrical energy. So, in this session, we have clearly understood the main differences and the similarities between AC generator and the DC generator.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ ENCLAPS the Learning App.